Hi folks, Mr. Long here. So I've created a tool to solve systems of equations with matrices. It's actually called Gaussian Elimination is this process, and there's a lot of academic vocabulary that goes to it. There's reduced row echelon form, there's echelon form, there's a lot of academic vocabulary. I'm going to wait for those of you that move on and do this sort of thing in the university, of which quite a few of you will. You'll learn all that academic vocabulary next year. I want to make sure you understand the process because it's something that it can be challenging because it's a very long process to solve three equations with three unknowns. I do want to use this matrice-based approach because that's the approach that will be taught next year. I also happen to think it's the best approach. Many students from Queen's Commerce students to all of the engineering students, to those that take physics and chemistry, anyone that takes math. Sometimes you'll have to do this in biology if you take a stats course. You'll be solving systems of equations. So let's get going. That's a brief introduction. So what you're going to see, I've created this tool that what it does is it automates a lot of the mechanical things, so you won't have to add and subtract integers in your head and things like that. But you're going to have to tell the spreadsheet what to do in terms of what are called row operations. Okay, so the overall process is listed on the left of the spreadsheet, so you can look at that. But it's quite straightforward. I mean, the one goal you have to think of is that you're going to have three equations with three unknowns. You want to do what are called row operations, so multiplying rows by a number, adding and subtracting rows, putting one row, moving a row from the bottom to the top, things like that. There are three types of row operations. And you're going to do that to create a 2x2 system of equations, which is easily solvable. Okay, easily solvable. So here we go. So here's our original question, this one here. Okay. And there's our system of equations right there. 1x plus 5y plus 4z equals -7, and then the other two equations. So the first thing that you should notice about this is that the second equation and the third equation actually only have two equations. There's only two equations with two unknowns, y, z, z. So that's easily solvable right away. So in other words, if I can figure out what y and z are from these, I can easily figure out what x is from this first row. So one of the things I should do though is I should transfer all these numbers into the matrice, and so let's see, 1, 5, 4, -7, 1, 5, 4, -7. Okay, then I do -7, 9. Oh, wait a second. I got to be careful. That right there, what's the x coefficient there? How many x's are there? 0. So that's something to watch for when you're doing this. So that should be 0. That should be -7. The next one should be 9. And the next one should be 55. Okay, then it should be 0, 6, -8, and -48. Okay, -48. Now I've got my matrices set up. So why is this shaded dark green? So you're only supposed to enter things in the green. Well, this is shaded dark green because you want to look at this and go, if there are two zeros, like if there's a 0 in each of row 2 and 3, then I can immediately move to just solve the 2x2 system. Okay, I don't need to do row operations with the full matrix. I can just do the bottom two rows. Okay, and we're going to come back and deal with things like we always want to get a 1 in the top row, but right now that's not significant because we have two rows like so. Okay, so immediately what we do, if we have two equations, two unknowns off the bat, I go down to step C. Okay, so there's A, there's B, and there's C. So what I can do is if I go back up, I can take this right here. So I highlight those 8 cells, and I do Control C to copy or edit copy, and then I come down to here, and you can see it gives you the instructions. Enter the dark green region if there was a 2x2 system within the original 3x3, and there was. So what I do is I right click my mouse and I do paste special, and I only want to paste the values. Okay, so the values are pasted in there. The blue coloring, we'll deal with that later, okay? That's something that we don't have to deal with right now. Okay, so we have that. Now it's just a 2 by 2 matrix like you've already learned, right? So let's go through it. So the first one is negative 7 and 6. I'm just going to double check that that's right. Negative 7, 6, 9, negative 8, 55, negative 48. Yep, that's good. So I need to eliminate. Now, 7, like I've got a negative 7 and a 6 here, a 9 and a negative 8 there. It doesn't really matter. So I'm going to eliminate this column here. Remember that the first column is X, Y, Z, and then this is your constant, right? That's your constant there. So we want to eliminate the Y column. So first of all, are there any common factors? I forgot about that. That's always the first thing we do, is common factors. By the way, I would put your zoom to about 150% if you're on a laptop, and if you're on a desktop computer, probably it can be quite a bit bigger. You could go to 200%. Okay, so the first thing we want to do is divide out common factors. Are there any common factors across that row there? No. What about this row? Absolutely. They're all even numbers, so I can divide by 2. Okay, so now I've done that. Next thing here is, what do I do? So again, why would I get common factors? Why would I do that? Well, if you get a common factor out, it makes the numbers in the row smaller, and it makes mechanical operations easier if you had to do this by hand, right? Which many of you will have to do next year in your linear algebra course, or again, maybe in a stats course, which could be even in second year. Okay, so then you go to this one here. So now what we want to do is eliminate. Well, I've got a negative 7 and a 3 there. So I could multiply this row by 3 and this row by 7. And the reason I did that, I kept it with both with positive, is now I can add the equations, okay, or the rows. Row is an equation. So I'm going to be able to add to get 0. So I've already have it set up to add 1 row 3 plus 1 row 2. So row 3 becomes, the new row 3 is the old, one multiple of the old row 3 plus 1 multiple of row 2. And so you can see here I get that this is X, this is Y, this is Z. So negative 1Z equals negative 3. Well, what do I need to divide that row by? I got to divide that row by negative 1. Okay, so I'm dividing this row by negative 1, and that means negative, that gets divided by negative 1, that gets divided by negative 1, and that's X, that's Y, that's Z. So if I go over to here, I get to pick, so I've got it set up here that's a drop-down list, so you're going to pick X, Y, or Z for your solution. So I could say X equals 3, but it doesn't. Z equals 3. Okay, Z equals 3. So now what I have to do is called back substitution. So I've got to go up until I get to the initial, or we probably should go with the second matrice in the 2 by 2 system, okay, because I did some dividing there and made it simpler. But it doesn't matter, I can use the first one as well. But what I'm going to do now is so row 3 was used to figure out what Z was. I'm going to use row 2 now to figure out another variable. So I figured out Z, now I want to figure out Y. Okay, now I want to figure out Y. And if you notice, this is automatically filled in for you. Z equals 3. That's automatically filled in from down here. Okay, so you know that Z equals 3. So what do I have to do? I have to read this equation. So this equation says there are negative 7, okay, so negative 7y, and then that's going to equal 55, which automatically fills in for you, right? Now remember that this is an equal sign right here. That line is an equal sign. So that 9z, I need to subtract 9z off both sides. So what I do is I've got 55 to begin with, and then I have to subtract 9z. So the way I'm going to do that is I'm going to put plus negative 9, so it means take away 9 z's. And what's z worth? Z is worth 3, so I fill that in. And then what I do is, it does it for you. It says negative 7z equals 28, because it simplifies. I've got the spreadsheet set up to simplify that. And then it'd be 28 divided by negative 7, which is negative 4. So now I know that z equals 3 and y equals negative 4. Do I have all three unknowns yet? No, I need to get z. I go back up to row 1 for that. So notice row 3, row 2, row 1. There are many other ways to do this, but this is a pattern that works every time. Okay, so which matrix am I going to use? I'm probably going to use the one where I've taken out the common factors because that's simpler. So again, this time I'm using row 1. 1x, 5y, 4z equals -7. Notice the -7 colored in red here corresponds to this -7 here. You don't have to input that, it pulls it automatically. So how many x's do I have in this row? 1x. Okay, so I need to change, I need to change that to 1. I need to change this right here to 1. So I've got 1x, -7. Now I've got 5 y's and 4 z's, but I have to subtract 5y and subtract 4z to isolate this x, remembering that that's an equal sign. So again, it's going to be -5 groups of y, and what's y worth? 28. No, it's not 28. It was not 28, definitely. That should be, what should that be? What was y worth? Y was worth -4. That's interesting. So let's just, y was worth -4. So I'm just going to make sure that that pulls that in correctly. There we go, -4. So plus, so y is -4. And then what about z? We've got to take away 4 groups of z. So that's -4 there. And z is worth 3. Okay, 3. Whoops. That's a bracket there that I missed. And that should be, 3. Okay, so what that does then is it tells me that all of this, when it's simplified, -7 plus -5 times -4 plus -4 times 3 works out to 1. 1x equals 1, therefore x equals 1. And those are my 3 solutions. Z equals 3, y equals -4, and x equals 1. And you can compare against what was given in the initial question. Okay, folks, I'm going to do one more, on number 2, and we'll go through the process again. You will get used to this. And I think with the spreadsheet, it really, really speeds things up. And that's what I want you to be able to practice and go through them fairly quickly. Okay, so here's number 2. Number 2, here is our matrix C here. So again, look at this. 4x, 2x, 5z, 7z. It looks as though I have a 2x2 system within the 3x3 system. So that means life's going to be good. I don't have to worry about eliminating any variables in row 2 and row 3 until I treat it as a 2x2 system. Remember, you're going from a 3x3 system, then you're simplifying until you get a 2x2 system, then you solve. Okay, so this one should be, if I'm reading across the first row, 1, 2, 5, 23, and then now that's x and z. So where do I have zeros? Under y. Y is the second column, 0, 0. So in the first column I have 4, 0, 5, 16. In the next column I have 2, 7, and 28. Okay, so what I can do now is, or 26, whoops. Okay, so what I want to do now is, again, I have 2 zeros for the same variable, so I can copy that down and go directly to part C. So part C, and then remember, here is I do paste special, values only. Okay, so do we see a common factor? That's the first thing you're looking for in those 2 rows. And again, it's a 2x2 system in terms of x and z, right? I have the x value and the z value. The y values are 0. So it looks to me like there's no common factor to pull out, so I can go down to this section here. Now I need to get coefficients equal so I can eliminate. So what am I going to do? I've got a 4 here and a 2 here. Is there a way that I can eliminate easily there? Yeah, if I double the third row, R3. So I'm going to multiply that by 2. So now what I can do is just subtract rows. Now, I could multiply by -2, right? And then I would add. Now, that's probably a little bit easier to multiply by a negative and add. So, you know, some people say every time you should always add. I'm not quite that strict, but it is easy. I would agree that it's easier. Okay, so there are times, though, when you want to just, you can see right away, so you subtract. If you've got good number sense, it doesn't matter. Okay, so here we go. We're going to do that. So again, we're just adding 1 of R3 plus R2, and that's the new R3. So that's already done for us. You know, like if I would have had -1 there, you can see that that wouldn't have helped because I wouldn't have eliminated X. But I have 1 and 1, so that means I'm adding a 1 here and a 1 here, means I'm adding the rows. And now we can see that -9z equals -36. So what do I need to divide this row by? By -9. Okay, I divide by -9 and I end up with, and again I could pick X, Y, or Z. I'm picking not X. No, I should be picking Z. Z equals 4. Now I back substitute. Okay, so I know that Z equals 4. I'm back substituting. So again, I'm at row 2 here. So how many Y's do I, or sorry, that's X's in this case. How many X's do I have? 4 X's. So I've got to change that to a 4 and change this to X equals. Okay, so, and you see automatically how that changed that to X there. And the 16 stays there. I need to get this 5Z on the right side of the equation. So I've got to subtract 5Z. So that's going to be -5. And what's Z worth? Z has been calculated as 4. So if I look at this, 4x equals -4, x equals -1. Okay, I'm dividing both sides by 4. That's done for you. Remember, the only place where you have to put numbers is if it's green. Everywhere else, calculations are done for you. Okay, that's the first back substitution. We used row 2 within the 2 by 2 matrix. Now we go back up to your very original one. Okay, your very original one. And so the first known was, as we said, 4. The second known was, oh, that's a mistake still, isn't it? So let's make sure that we get that. I'll correct this for all of your spreadsheets, no worries. This X should be, the second known was X equals -1. Okay, here we go. So now I read across row 1. Row 1 says 1X, and then there's 23 on the right side. Now I have to subtract 2y and subtract 5z, right? If this was -2y, then I'd have to add 2y, because remember, that's an equal sign there. So I'm going to have -2 of x. What's x worth? -1. And then I'm going to need -5 of z, so that's going to be -5 there. And what's z worth? Z is worth 4. Okay, and I work through that. And, it's giving me x equals 5. So, and I think x is supposed to be -1 on this one. So just a second here. So what was the mistake, folks? What did I do wrong there? Well, you see, I knew x was -1 and z was 4. And then I decided I was going to solve for x again. That's not going to help. So what I'm actually solving for here is y. Okay, I knew what z was. I also knew what x was. Now I need to solve for y. So if I look in that first row, 1x plus 2y. So that should be 2y equals this 23. And now I have to subtract off that 1x. So that should be -1x, which is -1. And then I have to subtract off 5z. Okay, subtract off 5z. And so 23 plus -1 times -1 plus -5 times 4 is 4. 2y is worth 4. Divide both sides by 2. Y equals 2. So, and I can check my answers. Y is 2, 2. X is -1, -1, 4, and 4. Okay, and we're done. The next one, things are just going to get a little bit more complicated.